Hey, ladies and gentlemen, we're going to do 7-3 notes today on combinations. Okay, so combinations are very similar to permutations, but we're going to look at this introductory problem and then just talk about why they're different. A basketball team or basketball league has 5 teams. 2 of the teams are chosen to play one another. How many different possible matchups are there? Make a list. Okay, so we're just going to call our teams A, B, C, D, and E. Okay, so A could play B, A could play C, A could play D, and A could play E. We could have B versus A, B versus C, B versus D, and B versus E. We could have C versus A, C versus B, C versus D, and C versus E. We could have D versus A, D versus B, D versus C, and D versus E. And we can have E versus A, E versus B, E versus C, and E versus D. Now, if you notice, I listed out all the possibilities, just like we did yesterday with the drive-through versus counter example, where if Katie is working the counter and Bob is working the drive-through, that is different than Bob working the drive counter and Katie working the drive-through. Now, today, if we are talking about basketball teams playing against each other, A versus B is the same thing as B versus A. So I can get rid of that. Okay. C versus A is the same thing as A versus C. And BC is the same here. And then if we look here, D versus A, D versus B, D versus C, and then AE, EB, CE, and DE. Sorry, that's not a blackout, that's just the cat. All right, so you'll notice we cut down by quite a bit. So let's count up how many possible there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible matchups of basketball teams. Stay over there, Rotor. All right, so I'm going to have you guys go ahead and jot these down about combinations. Combinations is an arrangement or a listing of objects. Woo, darn cat. None of you have that problem, right? All right. In which order is not important. So basketball team A versus basketball team B is the same thing as basketball team B versus basketball team A. They're the same. All right. So go ahead and pause the video here and chat down or write down the formula and that verbiage there. All right, so I'm under the assumption that you paused the video so that you could do that. So let's go ahead and just like we did yesterday, let's try a couple of problems here with just using the formula. You'll notice the formula for a combination looks just like for a permutation, except for we have this extra R here. And that R factorial is taking out those extra repetitions. Remember how we talked about permutations with repetitions? Same idea type here. With combinations, we're pulling out those extra repetitions. All right, so we get n is 6 and r is 2. So 6 factorial or 6 minus 2 factorial and then another 2 factorial. So 6 factorial over 4 factorial, 2 factorial. Now 4 factorial and 2 factorial don't combine to make 6 factorial, just know that. So we get 6, 5, 4, 3, 2, and 1. And then we have, I'm going to do 4, 3, 2, and 1. And then we have this other 2 and 1, so 2 and 1. So just like yesterday, all of the 4s and down are going to cancel. And then I'm going to simplify this 2 and this 6. I don't have to. I could multiply 6 times 5 and then divide by 2, but I like to make things simpler. So 2 and 6 are going to simplify to 3. So now I'm left with 3 times 5 on the top. So we have 15 for our solution. All right, let's take a look at the next one. Our n is 8 and our r is 3. So 8 factorial over 8 minus 3 factorial. Factorial is on the outside. And then another 3 factorial. So 8 factorial over 5 factorial, 3 factorial. So let's go ahead and jot those out. 8, 7, 6, 5, 4, 3, 2, and 1. And then we have our 5 factorial. And then our 3 factorial. 3, 2, and 1. All right, so I'm going to simplify. Anything 5 and under is gone. So here I have a 3 times 2. So 3 times 2 is going to give me 6. So I'm going to cancel that 6 out on the top. And now we're left with 8 times 7, which gives us a total, oops, that's off, is of 56, a total of 56. All right. If you want to pause and rewatch that, that's great. Email me if you have questions. Otherwise, let's go ahead and check the next one. It says a group of 7 seniors, 5 juniors, and 4 sophomores volunteered to be peer tutors. Mr. Picard needs to choose 12 students out of the group. How many ways can he choose? Can 12 students be chosen? So it doesn't matter anything about how many freshmen, how many sophomores, juniors, or seniors are chosen. It's just picking 12 out of that total. So how many total students do I have? 7 plus 5 gives me 12. So I have 16 students. That's the end. And we are choosing 12. All right, so I'm going to plug those in the formula. 12 factorial, 16 factorial over 16 minus 12 factorial, and then 12 factorial. So 16 factorial, 4 factorial, 12 factorial. Now, when I write this one out, I'm not going to write out all of my 16 because I know anything from 12 and down is going to cancel out with this 12 factorial. So I have 16, 15, 14, 13. Oh, and I don't need to write my 12. Over 4 times 3 times 2 times 1. Okay, so I'm looking for anything that I can simplify here. This one may not simplify totally super simple, but it's going to simplify some. So my 4 and my 16, I can simplify that. So I get a 4. My 5 and my 3, I can simplify that. So I get a 5. And then my 14 and my 2, I can simplify that. So I have a 7. So now I have 4 times 5 times 7 times 13. So grab your handy help calculators. 4 times 5 times 7 times 13, and I get 1,820. Different ways we can pick 12 students out of the 16 that there are. All right. You and 6 friends are going to lunch. You can only take 2 people with you in your car. How many different combinations of friends could ride with you? Okay, so my question to you to think about is, are you going to include yourself? Well, we're not going to right now. You have 6 friends and you can take 2 of them with you. Your N is 6 and your R is 2. We have 6 friends and we're choosing 2 of them. So I'm just plugging it into the formula there. And I am simplifying it to 6 factorial over 4 factorial, 2 factorial. Again, I am not going to write anything below the 4 because that's going to cancel out with the 4 factorial. So I get 6 factorial, 5 factorial over 2 times 1. So my 6 and my 2 are going to simplify, and I'm left with 3 times 5. So there are 15 possible ways that I can bring 2 friends with me out of the 6. All right, let's go ahead and turn to the backside. So a gym coach selects a team of 4 athletes from 14 athletes to represent the school at the track and field meet. Find the number of teams the coach could make from this. So we have 14 athletes that we have, and we're going to choose 4 of them. So my N is 14 and my R is 4. Okay, go ahead and pause the video here and see if you can try and plug it in and calculate this all out by yourself. And when you come back, we can look at it. Okay, so plugging it into the formula, I got 10 and 4 on the bottom. I didn't have to write anything below 10 because that all cancels. My 4 times 3 turns into 12, so I canceled that with my 12 on the top. And then I simplified my 4 or my 14 and my 2 to get me 7. So I have 7 times 13 times 11, so 1,001. All right, so permutations and combinations are very similar. So we're going to look at some problems and we're going to have to decide, is it a permutation or a combination? And then we're going to calculate what we get, okay? So a subway car has 8 empty seats. At one stop, 5 people enter the car and nobody gets off. How many ways can the 5 people arrange themselves, in the 8 seats? Okay, so this is going to be a permutation because you're putting yourself in a seat, and that is a position. All right, so our total number of seats is 5, and 8, and we're choosing 5 of them. So N is 8, and R is 5. Now remember, our permutation formula is almost like our combination one. We have 8p 5. We have 8 factorial over 8 minus 5 factorial. So if we simplify that, we have 8 factorial over 3 factorial. So I can skip writing anything from 3 and below. So 8 times 7 times 6 times 5 times 4. All right, grab your calculators. And as you can see, I'm just using a basic standard calculator for these. 8 times 7 times 6 times 5 times 4. We get 6,720 different ways that those 5 people can fill those 8 seats. All right, a history test lists the names of 5 presidents. Each student must choose 2 of them to compare in an essay. How many pairings are there? Okay, so here you have 5 and we're picking 2. It doesn't matter the order that you pick the 2 in, okay? So you can say you're going to compare FDR versus JFK. The same thing as saying I'm going to compare JFK versus FDR. So this is a combination. It doesn't matter the order. So my N is 5 and my R is 2. I have 5 people and I'm picking 2. All right. So 5C2, 5 factorial, and then 5 minus 2 factorial, and then another 2 factorial. Don't forget, you have to add that extra one in there. So we get 5 factorial over 3 factorial, 2 factorial. So I'm not going to write anything from 3 and down because that's going to cancel with that 3 factorial on the bottom. So 5 times 4 over 2 times 1. Well, I can simplify the 4 and the 2. So we get 5 times 2. So there are 10 different ways that you can pair up those 5 presidents. All right, a survey asked people to rank basketball, baseball, tennis, soccer, and football according to how much they enjoy each sport. How many possible responses are there? Okay, so whenever you hear the word rank, it's automatically a permutation. All right, so let's go ahead with this one and go. Then we will have an N of 5 and an R of 5, which seems weird, but it'll work out just fine. So we have 5 factorial over 5 minus 5 factorial. Now 5 minus 5 gives me a 0 factorial on the bottom. And so don't worry about that. We're not dividing by 0 or any of that stuff. So we're just left with 5 times 4 times 3 times 2 times 1 in my numerator, and that's going to be what my problem is. So 5 times 4 times 3 times 2 times 1, and we get 120 different ways people could rank those 5 sports. All right, there are 20 students in the speech club. 3 of these students will be chosen to represent the school at a regional competition. How many different groups of students? 3 students can be chosen. So here you have 20 students, you're picking 3. It doesn't matter. We're not ranking them, we're just grabbing 3 of them. So this is a combination because the order doesn't matter. So my N is 20 and my R is 3. So 20 factorial over 20 minus 3 factorial, and then another 3 factorial. So we have 20 factorial over 17 factorial, 3 factorial. Now that 17 factorial is going to make sure that we don't have to write anything from 17 and below. So 20, 19, and 18 over 3, 2, and 1. All right. So my 3 and 2, 3 times 2 gives me 6, and I'm going to simplify that with my 18. So 3 times 2 is 6, 6 with 18 gives me a 3. So I'm left with 20 times 19 times 3. So grabbing my calculator, I have 1,140. Different ways that we can pick 3 students from the speech club. All right, last problem. How many ways can the letters in the word combination be arranged? Okay, so when we're talking about using a letter and not repeating it, this is a permutation, even though we trickily use the word combination in here. All right, so count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and do we have any repeats? I have an O and an O, so there's 2. Okay, and then I have an N and an N, so there's another 2. And I have an I and an I, so there's another 2. Okay, do I have any other repeats? Nope, I don't think so. Okay, so I have to write this out. I get 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. And I have 2 times 1, 2 times 1, and a 2 times 1. I'm just going to use a different color to cancel them. So the last 2 are going to cancel. Now I have a 2 and a 2, so I'm going to cancel that 4. So what I'm left with is 11 times 10 times 9 times 8 times 7 times 6 times 5 times 3. So I'm expecting to see a big number for this one. 11 times 10 times 9 times 8 times 7 times, oops, I hit 5 times 6 times 5 times 3. Oh yeah. We get 4,989,600. So 4,989,600. Whew, we survived another day of notes. Go ahead and do your 7.3 homework, and please reach out to me if you have questions.